Hello and welcome to our first webinar, VacuDry 21st Century Thermal Desorption, the benefits of low vacuum in thermal processing. My name is Michaela Zeus. I'm Customer Relations Manager here at Econ Industries, and I will be your host today. You may wonder why Econ decided to a webinar as well. Customers and partners are very important to us. And in the past, we have traveled the world in order to attend conferences and trade shows, in order to exchange ideas, share and exchange knowledge. So we also travel to see our customers to find out about their needs. Clearly, right now, all of this isn't really possible. So we were looking for another platform. And we decided the webinar might be a good place and a good way to go, hence this webinar. So, but what is our goal for us today, or for you, what we would like for you to achieve out of this webinar? We would like for you to better understand what is out there, how our technology works, how it differs from others, in order to gain more knowledge and be able to make better informed decisions regarding your projects. So now, what is the market situation? We have one, increased hazardous industrial waste. And it's not going to go away, it's only becoming more. And it's not just the chemical industry, the mining or the quarrying. There are a lot of other industries involved as well. Second, you will see more mergers and acquisitions and also product launches, especially from the major players. And this in return can have an effect on prices. Three, the circular economy. The circular economy is all around us. It's a buzzword and it's not going to go away. It's going to stay. But what does it mean? It really means where nothing is wasted and natural resources are managed sustainably. So what does that mean for the hazardous waste industries? The recovery of resources should always come ahead of incineration or landfilling. And four, the government. Rules and regulations will become stricter and stricter. They're not going to go away. We have seen CO2 prices. We know of caps on VOCs and so forth. So there's a lot to consider. We need to be mindful of the long-term investments we decide on today, given the ever-changing parameters around the treatment of hazardous industrial waste. Now, I don't want to let you wait much longer before we start, but I want to talk a little bit about the technicalities around this webinar. We will record the webinar, so in case you missed something, don't worry. You can always send us an email at sales@econindustries.com, and we will send you a link where you can download the webinar. So if you missed something or want to review or revisit something, you can do so. You will not be able to speak during the webinar. We're just too many attendees. However, at the bottom of your Zoom page, you will see a tab that says Q&A. Or depending on whatever language you have chosen, it might sound differently or look differently, but it's a question and answer tab. And we encourage you to ask many questions. You can do so throughout, and after the speakers are done with the presentation, we will have a question and answer session, and hopefully we will be able to answer your questions. So now I don't want to keep you any longer. I would like to introduce the two speakers of today. I have Reinhard Schmidt, the CEO of Econ Industries with me. He has a wealth of experience. He's been in the industry for many, many years. And then we have our other speaker, Alejandro Castilla. He's our sales and project manager, and he tackles different industries, different materials all day long. So I'm very happy to have both of them here with me. And now, so you know what you will be expecting for today, I will quickly share the agenda, and then you will see what they will talk about today. So we have the market position. Reinhard Schmidt will talk about that. When we talk, then we will talk about the working principle, typical applications, main benefits, and we will finish off with a system comparison, and then after that we have a short Q&A session. So now I'm happy to give the mic to Reinhard to tell us a little bit about the market position.
So Michaela, thank you very much at first for your great introduction. Thank you to the entire team of Econ Industries to prepare this webinar today. And thanks to all the attendees today, more than 60 people around us, and we have learned that this is a good opportunity to get in touch with you. So starting with Econ Industries and the VacuDry market position, we want to give you a short introduction into what drives us in our everyday business. Our intention is to provide the most efficient and cleanest solutions to recover resources from industrial hazardous wastes. So our focus is and remains hazardous wastes treatment. Our VacuDry technology is a low temperature vacuum distillation process for safe and efficient recycling of resources from wastes, with the target to separate contaminants like mercury and hydrocarbons from solids like minerals and metals. So what drives us is making clean recyclable materials available for reuse to supersede on a long-term basis landfilling and incineration, to reduce significantly CO2 emissions in waste treatment, and to avoid waste export and large waste transport. Next, please. Yeah, Econ was founded in 2003 as a machinery supplier. We are based in Germany, in the southern Bavarian part between Munich and the Alps. Very nice area, by the way. We have been winners of the Export Award of the Bavarian Ministry of Economics in 2018. We have representatives in many, many countries, amongst others in the UAE, Australia, Canada, China, and Russia. And internationally, we are very much involved in international working groups, like in the UN, and especially also with our mercury activities in the Minamata Convention meetings. This is all based on our VacuDry solutions, where we present and try our best to separate the contaminants and the pollutants from the industrial wastes. Next, please. Over the years, we have delivered all in all 30 hazardous waste treatment projects, from which 16 are based on VacuDry technology. VacuDry plants are based in 3 different continents today and in 12 different countries. More than 1,500 tons of solid and pasty industrial wastes are recycled every day in our VacuDry units worldwide, mainly hydrocarbon and mercury-based wastes. We have experience and knowledge with over 500 different waste streams that have already been treated in these units, including contaminated crushed building rubble and soils, landfill residues, tank sediments, sludges, filter cakes, centrifuge cakes, spent activated carbon and catalysts, and even now in metal containing chips and grinding swath. At the moment, we are currently commissioning 3 new plants in India, Switzerland, and Brunei. Just to show you 6 out of our 30 references, a mercury waste treatment plant in Australia, a mid-sized one, not that large. The next one is a drill cuttings treatment facility in Azerbaijan, or 2 drill cuttings treatment facilities in Azerbaijan, dealing with 70,000 tons per year of drilling wastes. Hazardous waste treatment in Australia, in Melbourne area, in Germany since almost 10 years now, metal sludge treatment, especially grinding swath from car and bearing manufacturing. advanced soil treatment with mercury and PAH contaminated material. And another example is mercury treatment stabilization in the UK. Just 6 out of 30 references to give you an impression on where we are active and what kind of treatment we do. So this should serve as a first introduction, and now I hand over to Alejandro and Michaela for the next step in our webinar.
Thank you very much, Reinhard, for telling us about Econ Industry, how we work, what drives us, and the accomplishments that we have achieved. For the next part, Alejandro will tell us about how the VacuDry actually works. So please, Alejandro, tell us a bit more about it.
Okay, thank you very much, Michaela, for the introduction, and the same to Reinhard. So I will start in the working principle with a short video, and in between, I will be explaining to you how this process actually works. So the first process starts with the fitting of the unit inside of the batch-wise working evaporator, and this can range from various types of sludges to contaminated soils and in general more weathered material. During the fitting, the auger of the evaporator is rotating, and thanks to the connected shovels, the material is homogenized and equally distributed inside of the evaporator. Continue. Exactly, perfect. So once the fitting is complete, a vacuum gate between the fitting system and the evaporator gets closed. As you can see, there is thermal oil that is flowing in a heating jacket around the evaporator and also in the central shaft. This way, the material is indirectly heated. Here, it is also important to highlight that the same temperature is applied to a vapor filter system, which is actually sitting directly on top of the evaporator. And this avoids that fine material or fine particles pass into the condensation unit. Next, please. So during the VacuDry process, the pressure is set to around 50 millibar absolute. And as the temperature rises, the water and the different contaminants start to evaporate. The thermal oil has a maximum heating temperature of 400 degrees Celsius. And this represents an effective material temperature of up to 350 degrees. But now, when you consider the vacuum, this corresponds to an evaporation capability at atmospheric pressure of around 450 degrees. Yes, so in other words, we require on average 4 times less energy than other desorber types. Next. So the first evaporation and condensation phase belongs to the water content present. And once the material temperature keeps rising, other resources get recovered. So substances that before were contaminants now are recovered resources. The remaining vapors pass through a powerful vacuum pump system where a chiller allows to collect volatile organic compounds. And an activated carbon filter follows before finally releasing the exhaust into the atmosphere. So once the batch is finalized, the material drops into the discharge unit and the fitting of the next batch takes place. As you can imagine, the material has a temperature of around 330 degrees and it needs to be cooled down. So we use cooling screw conveyors and drop the temperature to below 80 degrees. For some of our customers, it is important to get back moisture into the material so that this is not dusty. And this can be used actually with the water that was condensated and recovered in the previous stage. This way we have, let's say, also the clean solids. Next. Okay, so now another way of presenting to you the working principle of our plants. This is a flowchart, and I like this version actually a little bit more because it shows the modulars, the different modules of our plants. So all our plants are executed in a modular design, and this is to reduce transportation costs and to enable a fast commissioning and installation on site. As you can see, the first unit is the feeding unit. Then we continue with the evaporation unit, the discharge unit, the condensation unit, the thermal oil unit, the operating resources, and this module consists of the instrument, air, and nitrogen generation and distribution system. For example, for the treatment of oily wastes, we need nitrogen in the process, and the cooling unit, and finally, the control unit. So now I want to speak a little bit more in detail about the evaporation unit and the condensation unit. Further units will be explained in other webinars once we also tackle specific applications such as metal wastes or oily wastes. Next. So here you can see an example of the installation of a vacuum drive 12,000 evaporator, and what this number actually means. So the 12,000 refers to the gross volume of the evaporator. So we're talking about 12,000 liters or 12 cubic meters. And we build, let's say, evaporators that range from 1 cubic meter up to 15 cubic meters. On the right side, you can see the vapor filter system. And in that particular case, we have 2 units working in parallel. So that's why you have the 2 evaporators directly one next to the other. In the bottom picture, you have the heavy duty design of our evaporators. So you can see the central shaft and also the connected shovels. Here it is important to mention or to highlight that the minimum wear is mainly due to the slowly rotating parts. And by slowly rotating parts, I mean around 5 turns per minute. Next slide, please. Here, those are 2, let's say, examples also of the installation of condensation units. The condensation unit in general allows us also to recover water and oil and other resources as separate fractions. Also, we have automatic discharge to storage vessels, as you can see in the bottom right side of the pictures. And our systems also count with redundant vacuum pumps. So there, for example, you can see that there are 2 pumps next to each other. In case one stops working for any reason, there is always a backup. Also, our process designs allows maintenance of critical parts during operation. Next. Thank you.
Thank you very much, Alejandro, for telling us about the process in such detail. I know this can be a lot to digest, so this might be a good time to remind you, please ask your questions in the Q&A tab of Zoom, because it is a lot, and sometimes it's just good to ask any question you may have, and we're happy to answer them later on in our Q&A session. Now that we have learned so much about the process and how it works, what are the typical applications that we can do and use? So Reinhard will tell us about those.
Yeah, thank you very much for this introduction into the vacuum drive working principle. By the way, Alejandro is just with us for almost 2 years now, and he's definitely doing this description better than I do. So great job, Alejandro. Typical applications of the vacuum dry unit. As we have learned, we are separating substances having a boiling point of up to 450 degrees C. So if we don't meet substances that totally boil at this temperature, we are also in a position to decompose substances to evaporate the volatile parts of their earlier compounds. So with regard of metallic mercury evaporation, this works perfectly because the initial boiling point of mercury is 357 degrees. So we can desorb from sludges and from contaminated soils the metallic mercury easily in our process, only at temperatures at around 300 degrees due to the vacuum. Hydrocarbon evaporation works up to, let's say, hydrocarbon chain lengths of C40. Around C40 is what we can evaporate easily. So this is in the perfect range for drilling fluids, because normally oil-based mud fluids are in the diesel range with the boiling point of around 300 degrees, 280, 260 degrees C. So we can evaporate oil-based mud fluids as well as synthetic-based fluids at a temperature range, treatment temperature of only 200 degrees. We are treating crude oil and refinery waste as well as tank bottoms. And this works in a way, as I said before, that we evaporate up to C40 chain lengths the involved hydrocarbons. Filter cakes from chemical physical wastewater treatment, we can make hydrocarbon free. The metal sludge and the grinding swarf, we separate from metal machining the accordant hydrocarbons, and of course also solvent-based paint wastes can be treated in these units at temperatures at around 150 degrees C, including the vacuum, the solvents evaporate. Apart from this, we have this huge variety of pollutants and persistent substances. What we are talking about today is also soil treatment. And here from the PAH, CHC, PCBs, down to the PFOS and PFOA material, we can either directly evaporate these contaminants, or we decompose and evaporate the volatile parts. So typical applications means also that we want to show you the accordant wastes that we can treat. Here we see first mercury containing soils and let's say wastes on the more drier side. We see at second grinding swarf, we see paint wastes and refinery wastes, tank bottoms, so more liquid, pasty wastes with high hydrocarbon amounts. We see centrifuge cake and contaminated soils. We see spent catalysts and activated carbon. And last but not least, we see here nice pumpable drill cuttings, oil-based mud, synthetic-based mud. All these wastes can be treated in the same vacuum dry unit. You don't need different plants to treat the same waste streams. The industries we serve, so of course, we serve most industries that generate hazardous wastes. That's a unique technology for many types of different waste streams. And what is important to know, we treat batch by batch, no need to blend the wastes. So we serve the chemical industry, especially when it comes to solvent-based residues and mercury-containing residues. Especially new applications are the recycling of non-ferrous metals like copper from copper catalysts, for example. Also, rare earth materials have been treated, cleaned in our units. Oil and gas industry, I think I've talked enough about this. Metal-containing sludges is also an upcoming waste stream that becomes of more and more importance to substitute co-incineration of grinding swarf we can do recycling of these kinds of metal sludges, which are mainly coming from machining operations. Mill scale sludges from the steel industry can also be treated. In the biorefineries, a lot of different sludges occur, residues where we can remove the oil and gain dry solids. Industrial wastewater treatment in general, the filter cakes created there, especially in the chemical physical wastewater treatment, are one of our major waste streams that we are working on. So, talking about industrial wastewater treatment and the accordant filter cakes, this is a typical application, a unit that we delivered to Melbourne 5 years ago. Vacuum dry, in this case, terminated the final disposal of 20,000 tons of hazardous waste in landfilling. So we recover the water, of course, and the hydrocarbons from these wastes and get back a non-hazardous material. With this unit, mercury waste treatment in Australia, we terminated the export of 3,000 tons per year of mercury waste from Australia to Europe. With this unit, we recycle 14,000 tons of synthetic drilling oil from 70,000 tons of waste. This is based in Azerbaijan, where a large amount of drilling wastes occur from the oil and gas industry. With this unit, 100,000 tons of mercury and PAH contaminated soils have been treated on site for reuse, so that only a small amount of mercury, PAH, left the site, and the rest of the soils were reused on site for building purpose. Another plant here, which will also start operation in Brunei soon, it terminates 10,000 tons of co-incineration of oily wastes in cement kilns. Metal recycling, an upcoming issue with this plant in Germany that went into production in 2011 already. Dry prevents 10,000 tons of high alloyed material from co-incineration, and finally the metal powder goes back into the melting process. Another application with a smaller plant here, 1,000 tons of norm material, mainly from drilling, is prepared for long-term storage in salt mines by the vacuum dry unit. So that's my part with regard to the applications. And now Alejandro will continue.
Yeah, thank you, Reinhard, for the insight into the many different applications and materials that can be treated through the vacuum dry technology. I think it becomes clear that the technology has quite a bit of flexibility and can handle quite a few different materials. One of my favorites is how we separate mercury from contaminated soil in order to reuse the soil. But as you have seen, there's a lot more that the technology can do. So talking about benefits, Alejandro will be up next, and he will tell us about the main benefits regarding the vacuum dry technology. Alejandro.
Perfect. Thank you, Michaela. Thank you, Reinhard. Yes, so with the main benefits is, of course, of our interest to present to you what this technology can bring to you, and to make this, let's say, easy to get, I distributed this in technical and commercial advantages. And here, some detail of material treatment, operation, health and safety, and financing. So related to the material treatment in the technical advantages, as Reinhard mentioned, in the input material is the flexibility. So it doesn't matter how the material comes. If it's liquid, pasty, solid, it can be treated in the same unit, in the same evaporator. The highest quality of the recovery in the output materials. This is not necessarily only on the condensate side. It could be also on the solid side if it's metals that can be recycled, or if it's in the mineral fraction that can be used, let's say, as a landfill cover material. Lastly, the batch-wise full process control. So we are tracing boiling points, right? And whenever we know that we are going to process a waste that requires a higher or a lower temperature, this can be set in that way so that we are really optimizing and maximizing the throughput capacity of the plants. On the commercial advantages in the operation, we have that staff required for operation is actually 2 per shift. One operator that is sitting in the control unit, and one operator that is taking part of the feeding operation and taking look also while the discharge is taking place. But in between, this operator can even be doing other work for other applications. So when you consider a very slow, a very small, let's say, staff that is required, you are being able to save some money there. On the technical availability, our plants have more than 7,500 hours. And here only, let's say, routine maintenance is carried every 2 months or something for around 48 hours. So this is really an operation that it's, even though it's batch-wise, it can operate on a continuous basis. On the health and safety side, we have the exhaust volume. So our units only have, let's say, exhaust emissions of less than 100 cubic meters per hour. When you compare this to other desorber types, you will understand why this is so significant. All our plants have also the ATEX certification, so the protection against the explosive atmospheres. And something that also makes us very, very proud is in these 17 years or 18 years now, 0 accidents recorded. In the financing section, so we have also an extensive network with German and European first-class banks, and this allows us to help you with export credits opportunities or finance lease to really make your project, let's say, feasible. And from the side of the banks, they of course love this, since our units can operate for more than 15 years. So there is this relation where we can connect you with a financial institution and help you realize your project. In the next slide, I have one example from the oil and gas industry. Let's say oil-based mud or synthetic-based mud cuttings. Here you can see in the bottom picture the high quality of those oils or synthetic drilling fluids, if that's the application. And this is mainly because there is no cracking or any process happening while we get the condensate. Also, all these units in the heating system, it can be fired either by fuel oil, diesel, natural gas, electricity, biomass. The possibilities are really, really broad. And when we take a look at some key facts, for the case of oil-based mud or synthetic-based mud, we have that maximum material temperature of 250 degrees is required. So as we, let's say, learned before, this equals to around 360 degrees Celsius under ambient pressure. And with having a 99% oil recovery rate, we are also achieving that the TPH level on the solids is always below 0.5% or 5,000 ppm, but we can even go lower. So it is just a question of what is your requirement. If by let's say a tender process, you require that the solids have to go to 1%, we can, of course, optimize the process so that you can operate in that way. Next. Here, I would like just to give you an example with oil-based mode and synthetic-based mode. How is the reaction, let's say, or the effect on the electrical consumption side and the thermal energy side? So in the graph, you have the two lines. So the blue one corresponds to the thermal energy and the green one to the electrical consumption. And each of these points refers to a different material composition. Here it is important to highlight that the higher the solid content in the material and the lower the oil and water content in the material, the less the energy it is required for each of these batches. And once we combine this and take a look on the throughput capacity, is where we can see the real impact also afterwards in the economics. So in our case, we support also your project not only by providing you, let's say, vacuum dry technology. We can also support you if you require some advice for a mechanical separation process or pre-treatment process, such as a centrifuge, where you can bring the material, let's say, from a 60% solid content to maybe 70 or 80%, and you can then increase the throughput capacity and get the most out of our units. Next. Thank you.
Thank you very much, Alejandro, for showing us the main benefits, and especially with examples. So I hope that this part has made it clearer for you what the benefits are and how it could be of use to you as well. And last but not least, we will compare different technologies, and Reinhard will show us these.
Okay, thank you very much for all these further information about the benefits of the vacuum dry process. I've seen in the Q&A and also in the chat a couple of questions around the technology and how it is used and maybe how it is compared to other desorber types. Maybe we can answer a little bit about this system comparison by highlighting difference between the use of rotary kilns and the use of vacuum dry technology. One of the main competing technologies in the oil and gas business, as well as the soil remediation business, are the rotary kiln. As we all know, there are direct fired, indirect fired, but there are still a lot of direct fired ones. And nowadays, more and more of these direct fired units are banned from waste treatment operations in some countries, for example, in the UAE. And now the question is, why are these direct fired units outdated? Why are they banned in some countries? So now we can look into the differences in operating these units. We are referring here to an example of treating oily mill scale with 30,000 tons per year. This could also be contaminated soils. This could also be filter cakes. So it is just an example. The differences, the significant differences between the systems remain more or less the same. So as we have learned from Alejandro before, the input material flow into desorber types based on rotary kiln technology are continuous. They usually need an almost homogeneous feed. Often blending with other wastes is necessary for the direct fired ones, especially to reduce the calorific value. With the vacuum dry technology and the indirect heated process, we process the wastes batch-wise. So there's no need to blend the waste stream with other wastes. As long as we can get the material with accordant conveying equipment inside the unit, we can also treat it. Operating temperature. In a direct fired kiln, this is usually above 850 degrees C. In an indirect fired, maybe around 500, 600 degrees C. But these units are always running at the constant, at their maximum temperature. So you invest energy without having special benefit, especially when this temperature, evaporation temperature, is not required. With the batch rise process, we have a temperature of up to 400 degrees. But for drill cuttings, for example, we only need the heating of up to 300 degrees to achieve maybe 200 degrees in the material. So we can adjust temperature according to the required boiling point. Pressure inside the heating chamber, rotary kilns usually run at atmospheric pressure, so around 1000 millibar absolute. The vacuum dry units, as we have already learned, are below 50 millibar absolute evaporated. So this gives us at least 100 degrees C boiling point advantage. Now we come to energy consumption for the heating. This is here shown per ton input material. For a rotary kiln system, we have 1,300 kilowatt hour per ton energy required for heating. And this is normally provided either by natural gas, by fuel oil, or by liquid wastes, such as waste oil and solvents. The vacuum dry unit requires around 300 kilowatt hour per ton input material. So the difference is 1 megawatt hour per ton. In the vacuum dry unit, we can deal with all sources of energy that are available, including biomass, our own recovered condensate, and also locally emission-free, electrically heated, especially when it comes to smaller units. CO2 emissions per year based on natural gas we have calculated and shown here. So we are talking about the 30,000 tons treatment per year. So with the rotary kiln units, we produce around 8,500 tons of CO2 per year. With a vacuum dry unit, due to the lower consumption when operated with natural gas, we are in the range of 2,000 tons CO2 per year. So there's a difference of 6,500 tons CO2 per year. With the upcoming pricing on CO2 emissions, we are now experiencing in Germany a price of 25 euro per ton at the moment, and this will increase slowly but carefully to around 60 euro per ton CO2 in the year 2026. What is the result of this? Looking into the 8,500 tons CO2 multiplied by the 60 euro, this would mean an additional cost per year of around €500,000 only implied by the CO2 emissions. So a price increase over the next 5 years of around 17 euro per ton input material. For a vacuum dry unit, when operated with natural gas, the increase is only 4 euro per ton input material. When operated with biomass, it will be 0. Coming to the comparison of the process exhaust emissions, I also saw in the Q&A some questions about how the exhaust is treated. In a rotary kiln, a direct fired rotary kiln system, heating and process gases are mixed because the direct flame is used to heat up the contaminants. So this entire amount of more than 30,000 cubic meters per hour needs to be treated in the exhaust system, including possible post-combustion. Most of the rotary kilns are equipped with post-combustion chambers, so all the 30,000 cubic meters have to run through the exhaust system, including the post-combustion, and this, of course, requires energy. In our vacuum dry units, due to the indirect heating, the process gases and the heating gases keep staying separate. So on the process exhaust side, due to the vacuum-tight design of the entire desorber, we only have less than 100 cubic meters per hour. So with this tiny amount, little amount of exhaust, this can be handled in all the vacuum dry units that we already delivered without any post-combustion. So this is done by the chiller to undercool the exhausters, and afterwards we go through activated carbon filter, and then we are allowed to release the exhaust, the cleaned exhaust, to the atmosphere. There's only one single reason that makes it necessary to install a post-combustion, and there was one question from the Q&A with regard what happens with the PFC contaminations and with the accordant separation of the PFC in our process. The PFCs in the process are decomposed. Over the long term treatment, the batterized treatment of around 4 or 5 hours, the compounds break up into their initial precursors, and so that we cannot find them again in the condensate by 100%. So they leave the unit via the exhaust, and in this special case with the PFCs, we install a post-combustion at 1,200 degrees, because we have learned from the manufacturers of the PFCs that 1,200 degrees are required to make a safe post-combustion and to destroy the PFCs in the exhaust. So here we also learn that the currently operated rotary kilns that have post-combustions of maybe 1,000 degrees are not sufficient, according to the manufacturers of the PFC, to deal with the accordant exhaust. So another advantage here, when you only have to treat 100 cubic meters per hour of exhaust, by post-combustion is, of course, far cheaper and easier to manage than handling 30,000 cubic meters. So this is a quick comparison of rotary kilns versus vacuum dry systems. If you require more information, more detailed information, then just ask us in detail around this. Thank you very much for the moment.
And thank you, Rainer. Actually, thanks to both speakers, because now we have reached the end of the presentation part. So thank you, Alejandro, and thank you, Reinhard. And we wanted to finish at 10:45 with the presentation, so 5 minutes late. However, Reinhard has already answered some of the questions, which is great, because this is going to be the next part. So now that we learn how the technology works and what the benefits and typical applications are, and how it compares to other technologies, we would like to go into the questions next. Thank you very much to everyone for posting all these questions. We have received quite a few. And so I want to ask you already, if we won't be able to answer your questions, please don't hesitate to send us an email to sales@econindustries.com, which you can see now on the slide, because we want to make sure that your questions will be answered. But now let me start with the questions. Okay, we have one question that says, what is a typical delivery time for the vacuum dry units, and what other services do you offer? Is one of the questions.
Okay, Reinhard, if you want, I can answer this one.
Of course.
So the delivery time depends, let's say, on the various sizes, right? So the smaller units, or the ones vacuum dry 3,000 or 1,500, let's say, require a shorter delivery time. It could be from 6 months to 9 months or 10 months for the large units, but this depends also if there are special requirements to the units. So if there is a special requirement that you would like to combine to a previous site that you already have, most probably we will go first through a basic engineering phase where we clear all this information, and then we start directly with the manufacturing and the delivery. So 6 to 9 months X works. And other services. So of course, we not only deliver the equipment, so we are also for the supervision of mechanical and electrical assembly on site, and for the commissioning of our plants, training of the operators, and after sales services. This, of course, is part of what we offer. We also have the possibility of running tests with the material of our clients, so proof of performance tests in a facility that we have, a small vacuum dry plant. So yeah, and if there are other services that you require, I'm sure we can manage it.
Okay, thank you. The next question is, if we feed any pyrophoric oily sludge by mistake into a thermal desorption unit, what will be the outcome?
Good question. That is one of the big advantages of the vacuum dry system. It's fully operated under nitrogen atmosphere. So we always control the oxygen content inside the batch-wise working evaporating chamber. So if you get it safely in and you just experience by surprise it is pyrophoric at the end of the day, it doesn't matter for us. Yeah, because there's no risk in operating such material inside the vacuum dry batch-wise working vacuum chamber.
Great, thank you. So the next one is, for how many years can a vacuum dry unit be operated? And then there's a second question asking from the same viewer, Econ is a machinery supplier. Does Econ intend to operate an own vacuum dry unit or own vacuum dry units in the future?
So for the first question, yeah, vacuum dry units are in operation that we delivered for almost 20 years now. So it's quite a long lifetime with the same equipment. And on the other hand, yeah, we are machinery supplier, of course. Only in Germany we have on a midterm basis the intention to operate own vacuum dry units, maybe in a joint venture with other people. But looking into the worldwide business, we intend to stay as a supplier.
Thank you. So the next question, an oil cuttings treatment unit, what is the maximum treating capacity per hour?
So in the oil cuttings treatment unit in Azerbaijan, we treat 70,000 tons per year, so 8 to 10 tons per hour.
Thank you. And the next one is, how many?
Exactly, and maybe just to add something to that question from the smaller plants. So it starts also with a few hundred kilograms per hour.
Of course.
So not only large sizes that are available.
That's true, right? How many people are required to run the unit is the next question.
So normally one engineer is sitting in the control room to control the process and manage feeding and discharge, and one person is required for logistics and observation in the plant. So in overall or in the larger plants, 2 people are running the entire shift. Of course, in parallel, when you have centrifugation units in operation, for example, you can also manage in the same time with the same people the centrifugation units.
Right.
How will you separate dust from hydrocarbon vapors? Yeah, yeah, the dust stays in the dryer chamber. because we have the vapor filter sitting on top of the dryer, and so no dust emerges in the direction of the condensers.
And what is the average repair and maintenance cost per year, including the consumables cost?
Yeah, that's of course a little bit difficult to answer because it depends on the plant size and also of the abilities of the local staff. So we should look into the accordant equipment specifically and into the accordant application to give you this exact information.
The next question, can this unit
regarding
be...
mobile units?
Yeah.
Good question. Yeah. Vacuum equipment is a little bit heavier than normal thermal treatment equipment. So mobility is provided with our smaller units up to, let's say, 1 ton per hour oil sludge treatment. But the rest of the units are semi-mobile. It doesn't mean that they cannot be moved, but they are not sitting on trailers and cannot be moved on trucks day by day.
And can we handle oily sludge, which is having 50% moisture, 30% solids, and 20% hydrocarbons?
You are more than welcome with this material. Yeah, I can easily treat it.
So what is the typical processing capacity of a vacuum-dry system, and what variables impact the capacity?
First of all, of course, the less water is inside, the higher is the throughput. So it is highly recommended to separate water and oil in a proper centrifugation system before treating the material. So mainly the water. And of course, the boiling point of the contaminants are the drivers for the capacity. So
I was just reminded that we are very close to the end of...
We are running a little bit out of time, but...
Mine says 10:59. We have 1 more minute, and I'd say we do 1 more question, if that's okay, and then we will... So we have, how do you resolve the problem of dioxin and of PCB disposal? And then we quickly round up.
We did not experience the occurrence of dioxins in the exhaust stream, but if there would be, it is only, again, to mention, less than 100 cubic meters per hour means dioxin occurring would be easy to handle. But as I said before, dioxin do not occur due to the low temperature of the material in a range of 350 degrees only.
So thank you very much. Again, thank you to the speakers for telling us more about how everything works and where we're at and what we have achieved, what we want to do, and how we hopefully can help you. And that's why the biggest thank you goes to you for joining us today and also for asking all these questions. This is wonderful. Unfortunately, we haven't been able to answer all of them. So please don't hesitate to send those questions to sales@econindustries.com. But thanks again, and we hope that it really helped you gain more knowledge about how everything works. And we hope to see you at our next webinar, which will be announced soon. In the meantime, I wish you a wonderful day. Thanks for joining, and bye for now.
Okay. Thank you. Bye.
Thank you. Bye-bye.